Hi, I am E. Rajesh Kumar, Assistant Professor, Department of BES1. Today I am going to discuss the topic on Introduction to Nonlinear Data Structures. Here, starting with the aim of the session. The aim of the session is to learn and familiarize with nonlinear data structure. What is the instructional objective? That is to understand about nonlinear data structure and also the tree terminologies associated with trees, and to define the tree as hierarchical data structure. And what is the learning outcome? That is to know the importance of nonlinear data structure and also to identify all basic terminologies. Starting with the introduction, first of all we should know what is a nonlinear data structure. That is, a nonlinear data structure is a data structure in which data is stored in non-sequential order, where the data item in nonlinear data structure represents hierarchical relationship. Each data item is called as nodes. Here there are different types of nonlinear data structures, among those trees and graphs. Here I am just giving you a small example. First, as I am talking about nonlinear data structure, as I told you, all the data are stored in non-sequential order. So before this you can see like a simple example which has been given here about linear data structure. Linear is, here you can see where the data is stored in a sequential order. That is why it is linear data structure. But if you talk about non-linear data structure, here each and every data will be stored in non-sequential manner. Here some of the characteristics of non-linear data structures are, you can see that the non-linear data structure is efficient method of organizing and storing data, and also it is used to keep integrated data items when they are not available in continuous memory location. Here in nonlinear data structure, all the data is randomly stored in memory, and also it has effective utilization of memory. So under nonlinear data structure, here I am going to see about tree data structure. Here in tree data structure also all the data is organized in random order. Here the tree data structure is a collection of data which is nothing but nodes, which is organized in hierarchical structure recursively. Here starting with tree terminologies. Here first of all I have shown you a simple example here, a tree. In this particular tree, every individual element is called as a node. Here individual element indicates a node. Here A, B, C, D, E, F, G, H till J till K all are nodes here. If we have n number of nodes, then we can have a maximum of n minus number of links. Here links is nothing but edges. Here if you see like A is a node, C is a node. This A node and C node is connected with a line which is known as edges. Here if we have totally n number of nodes, we should have n minus 1 links. Say for example, if we have 11 nodes, it means that we should have 10 links. So in this example tree we have 11 nodes and 10 edges. Here every individual element is called as a node. Here the next terminology is edge. As I told you before, each and every node is connected only by using edges. In this example, the connecting links between any two nodes is called as an edge. Here A and C is a node which is connected by a line which is known as edge. There cannot be any node without connecting edges. That is, it means like edge should be there between two nodes. Here if you see, the next terminology is the root node. Root node is very important node in a tree. The first node is called as a root node. In a tree, the first node is said to be a root node. Here in the given example, A is highlighted here, which is a root node here. Every tree must have a root node, and also root node is the origin of a tree data structure, and there must be only one root node in a tree. The next terminology is a parent. In this example, you should know what is a parent node first. The node which is predecessor of any node is said to be a parent node. Parent node can also be defined as the node which has child or children. In this example, E, G and C, all these nodes which has been highlighted here are said to be a parent node. Why? Because from this particular node we have some predecessor node connected, which is said to be some child nodes. Here, as I told you, in any tree the nodes which has child or children is called as a parent. Next terminology is the child. In the given example, the node which is descendant of any node is said to be a child node. The node which has a link from its parent node is also said to be a child node. Any parent node can have any number of child nodes. All nodes except root are called child nodes. Here, in the given example, node B and C are children of parent node A. Here, node G and H is the children of C. Here, K is the child node of G. That is why we say a descendant of any node is known as a child node. Next terminology is siblings. In siblings, be very clear, nodes which belong to same parent are known as siblings. In simple words, you can say like the node with same parent are called as sibling nodes. In the given example tree, here node B and C are siblings, node D, E and F are siblings, node G and H are siblings, node I and J are sibling nodes. Here K cannot be the sibling node. Why? Because this particular node is a child node which has no sibling. Parent node of K is G. So this node has no siblings. Next is the leaf node. So the node which does not have a child is said to be a leaf node. And also a leaf is a node with no child. The leaf node are also called as external nodes. External node is also a node with no child. Leaf node is also called as terminal nodes. All these are some key points which is to be noted, especially in tree terminologies. In this given example, so be very clear, the node which doesn't have a child node is said to be a leaf node here. So node value highlighted here with D, I, J, F, K and H are leaf nodes. In any tree, the node which does not have children is called a leaf. And also, we also say it as a node without successor is called as a leaf node. It is very important. Next terminology is degree. So in the given example tree, we should know what is the degree of a node. So how to calculate the degree of a node? So first of all, how to calculate the degree of a node? The total number of children of a node is called as the degree of that particular node. The degree of a node is total number of children it has. That is here. First, the highest degree of a node among all the nodes in the tree is called as a degree of a tree. So here, first of all, you should know how to calculate the degree. Once if you know how to calculate the degree of a node, we can easily calculate the degree of a tree. Say for example here, I need to calculate the degree of the node value B. Here the degree of the node value B is 3. Why? Because it has 3 child nodes. I need to know the degree value of A. The degree of node value A is 2. Why? Because it has 2 child nodes. I need to know the degree value of f. The degree value of f is 0. Why? Because it has no child nodes. So that is why in any tree, degree of a node is the total number of children it has. Next terminology is height of a tree. So in general, how we calculate the height of a person? First of all, every time the height of any node is calculated only from the leaf node, that is the total number of edges from a leaf node to a particular node in the longest path is called as height of that particular node. So be very clear with the point, longest path. In a tree, height of a node, a root node, is said to be the height of the tree. In a tree, height of all leaf node is 0. Why? Because there is no node below that leaf node, so that is why the height of that particular node is 0. Here, say for example, I need to know height of the root node here. So if I want to calculate the height of this particular root node, be very clear, we need to calculate the total number of edges from this particular node till the leaf node here. Okay, so that is here height of the tree is 3 here. Why? Because here, say I am taking the leaf node here k, which is the leaf node. From this particular leaf node, I need to calculate the total number of edges, that is only in the longest path till that particular node. So I have from k to g, I have one edge here, from g to c second edge, from c to a it is third edge. So totally the height of that particular node is 3. So here I need to calculate the height of b here. So if I need to calculate the height of node value b, so I need to go to the leaf node. From this leaf node till a particular node b, I need to calculate the total number of edges, that is in the longest path. So totally 2 edges we have. In all possibility ways you have to check it, but see to it that we have to calculate only the longest path to calculate the height of a particular node. That is why in any tree, height of tree is the height of the root node. So if we need to calculate the height of the tree, we have to calculate the height of the root node. The next terminology is depth. So if you want to calculate the depth, it is opposite to height of a node. So we need to calculate the depth of a particular node from the root node here. That is the total number of edges from a root node to a particular node is called as the depth of that particular node. That is, in a tree, the total number of edges from root node to a leaf node in the longest path is said to be a depth of that particular tree. In other words, the highest depth of any leaf node in a tree is said to be depth of that particular tree. So depth of the root node is 0. Why? Because we have to calculate the depth only from the root node. So every time the depth of the root node is 0. Now I need to calculate the depth of a particular node value. So I need to calculate the depth of a particular node value k here. So starting from the root node, we have to calculate the depth till the node value k only in the longest path. So from here, from a to c, from c to g, and g to k. So totally 3 edges are there. So here depth of the tree is 3. So that is why here in any tree, the depth of a node is the total number of edges from root to that particular node. If I need to calculate the depth of node value e from the root node, I need to calculate the total number of edges in the longest path. So if it is e, it is from a to b and b to e. So the total number of edges is 2 here. So depth is 2. Next is we have to calculate the path. So here the sequence of a node and edge from one node to another node is called as the path between that particular 2 nodes. The length of a path is total number of nodes in that path. So in the below example here, say for example here I need to know the path from a to j. So the path between a to j is we have to visit all the nodes here, that is from A to B, B to E and E to J. And also here is a path between C to K, that is from C node you have to visit G node, and from G you have to visit K. This is how you calculate the path between two nodes. Here is some of the terminologies what we have discussed in nonlinear data structure and a tree data structure, and also these are all some of the reference books which will cover all the tree terminologies which will be useful in implementing the tree data structure concepts. Thank you.